Okay, so I will say, as far as your homework goes, I was just quick and lenient when I was checking them because I was behind so much, but I will not be like that from now on. Just like always, multiple choice has to have stuff written with it. Like a letter does not count. An answer does not count. Write stuff. I expect you to have questions on some of this right now. Make sure that you make yourself a note or star the ones that you need to come ask about, because I want to focus on the multiple choice until we get through it. And then after that, I'm starting with your questions, and I'll have stuff that we can go over in class. But if we end up spending the entire class period just going over questions you have, then I'll just push my other stuff to the side. So that stuff will become first after we get through multiple choice. So make sure that you don't just be like, oh, I needed a question, but I don't remember which one it was. Keep a note of which ones it was so that we can go over those eventually. One other thing that I wish I would have said yesterday before you guys left. Remember that we're starting from the most missed to the least missed. So I think some of you are walking out of here feeling a little deflated yesterday. We're starting with the hardest problems on purpose. So if you didn't get any right yesterday, that's okay. So I'm just kind of reminding you guys of that. All right, so, and just a reminder that you are having good notes to go with this, because this is going to be a double quiz grade. All right, so I was stopped here where I wanted to talk about all four of the different sampling techniques. So we've got stratified. What's another one? What's another one? And all right, so starting with these two we put into groups first. What do we want or know or decide about the stratified group? What kind of groups do we want to put in? Groups that are similar. Putting all freshmen together, putting all sophomores together, that sort of thing. With cluster instead, the group should do what? What? I heard different things I should hear y'all say. Should they be similar within themselves? They should be similar kind of to the what? Population. Now, does that mean it's going to be perfectly like that? No. But they're small groups that represent all the different pieces, hopefully. That doesn't mean it's going to be perfect by cluster, but something like if we were dealing with, if all we cared about was gender, we might pick by classroom, because in that classroom should be multiple genders. So like it shouldn't be like all girls or all boys in one class. The overall gender of the school should be reflected within each class overall. That doesn't mean it's perfect though. Okay, so then who do we actually select with stratified? Some from each group. So the equal number part, it's not always the same number from each group, but it's always, ideally it should be the same what? Like I might end up picking, it should be this proportional to the population. So I might pick 6 freshmen and 4 seniors if there are a lot more seniors than freshmen. The way around. Who do I pick for cluster? Can I pick multiple groups? So all that matters is if I pick one person in that class, I'm picking everybody in that class. I might pick multiple classes, but everyone in that entire group gets tested. So both of these methods should end up with a good reflection of the population. Here, I make sure that my different groups are represented in my population. Here, because these fairly well represent the population, taking one or some of them should still reflect population. Systematic, what do I start with? Before that. See, somehow order them. Do you want the order that you put them in to have something to do with what you're asking? No. So if we're wanting to know about like GPA and we put them in order by height, that would be a good thing. Then you said what? And what's a good word for that? Int or interval, whichever one makes more sense to you. So all four of those are random samples. They're just different specific types of random samples. So A, random sampling is not part of the sampling procedure. Well, that's wrong because all of those are sampling. All those are random sampling. Population is divided, which is not a characteristic. So random sampling is population is divided into groups that are similar on some characteristic. That is true with stratified. The strata, which is the name of the groups, are based on facts known before the sample size is selected. Is that true or false? Because I would know their height before I put them in order. Wait, no, sorry. I would know their grade level before I put them into grades, before I ask them about whatever we're asking about. And each individual in the population belongs to one and only one, yes. And then so we talked about this one is the definition for what? Simple random sample. And that's one of the ones I would say I would expect probably to know on AP exam. And so I know less simple random sample blank, but that's basically the definition of it.
So why wouldn't that also be true for
Okay, so let's say I'm randomly picking people to go on a trip. And I'm picking 4 people, and I'm picking one from every grade level. That means you and your senior best friend can't be picked together.
Okay.
And so that's where that idea is coming from. All right, 22. This one I think is a difficult problem as far as like what you would need to do with this, and I'll show you that written out answer key too. But this is one of those where I think you should be able to think through pieces and not have to do the problem and be able to get to the right answer. All right, so a game of chance is being played in which X, the number of points scored each game, has a distribution shown above. Which of the following is true for the sampling distribution of the sum of Y, which is on the scores of the game played twice? So looking at this little chart, I play a game. How many options are there when I play the game? 3. I can get 0, 1, or 2 points. And it shows the probabilities associated with those. Everybody with me? Some people just don't get that part to start out with. What Y is saying is I play the game twice. So let's start there with this. If I play this game twice, these are telling me the points I could end up with in two rounds. And so I think people get confused on where this problem's supposed to start. So are these the only values that I could get if I played twice? No. What are the values that I could get if I played? What is the highest I could get if I played twice? 4. What's the lowest? 0. Okay, so I got 0. That one doesn't have 4. Could I get 1, 2, and 3? Yes, there's a way that between those numbers twice that I could get a 0 or a 1 or a 2 or a 3. So that automatically knocks me down to just 2 choices. Are y'all with me on this? And if you're not, when I draw it out the actual way you solve it, I think it'll click for you if you're still a little fuzzy here. So now at this point, let's say I have no idea how to start this problem. I've got 2 choices. Is it binomial? Why? What does it mean to be binomial? Are there 2 options each time? So E is your answer, and I never had to solve this problem. But I want you to see how this problem is supposed to be. I'm recording. I played the game once. How many options do I have? I can get 0 points, 1 point, or 2 points. I played the game again. I could have had any of those options. Off each one of those options, I could have 0 points, 1 point, or 2 points. So if I'm here, how many total points did I have? If I'm here, how many total points did I have? So I'm going to do these color to make more sense of it. So here's 2, 2, 2, 3, 3, and 4. So those are my different options of points, which still got me to that same answer. Now, I would also write a 0.3, 0.4, 0.3 that was associated with each one. Anytime I multiply 0.3 times 0.3, I get what? 0.09. Anytime I multiply 0.3 times 0.4, I get what? So these are all 0.09, 0.12, 0.09. No, this one switches. I'm just multiplying down. 0.12, 0.12, and then when I multiply this one, it's 0.16. So the probability of me getting 0 is 0.09. Probability of me getting 4 is 0.09. How would I find the probability of me getting 1? Add these 2 together, so it's actually 0.24, and so forth, to be able to figure out the real answer. Yes. Right here. I went too far over. But this problem you didn't have to get there because of if you could think through it, yeah.
Why doesn't it like reset like the amount of points that you get for each? Oh, it's just a song.
Yeah. I mean, so your question is right. It's literally just because of that word that you're adding it up. Yeah. Other questions with this one? And like I said, y'all can ask questions that might have nothing to do with this problem, but might just bring up the question. Yeah.
Wait, so like once you get all the probabilities and everything, like the totals, how do you like add them?
Okay, so what it comes down to, and I should have written this out anyway. So now my options are, how many points can I get? I could get 0, 1, 2, 3, or 4. My probabilities associated with it, well, I only had 1 that was 0, that's 0.09. I had 2 that were 1, so I put those together. 0.24, 0.18, 0.16, 0.34. Like it's on the is it what's it say? 0.34. These two together give me 0.24. That's my only option there. Now while we're saying this, tree diagrams have two rules, the way I think about it. And that's a weird way to say it, but I think you understand what I mean. What do you do when you go down the tree diagram? So like 0.3 times 0.3 to get my 0.09. When I'm going across, I mean, I want that one or that one, so I do what? So that's why I always think is add across and multiply down. Honestly, I was a little bit worried about this one because, oh, no, this one's tough. It's not a hard problem, it's hard to get to the problem. What do I call that? A test statistic, but it's a test statistic of a p-value. Some people got confused with that with chapter 12. A test statistic was used to conduct a test on the null hypothesis that mu equals 1 against the alternative that mu does not, or mu equals 0 against mu does not equal 0. It gives us the p-value. A two-sided confidence interval is to be constructed. Of the following, which is the largest confidence interval, which is the largest level of confidence for which the confidence interval will not contain 0? Our null hypothesis has 0. When I have a confidence interval, if the number is here, we do what with it? As a test, if the number were here, what would we do? What would our result be as a test? Fail to reject. If it is here or here, then we reject. So that's the first concept that this problem is doing. And so what are we, I know I drew 3 lines. My blue-green lines would be if what number was one of those 3. This number is what I'm checking to see where it is. Now, actually getting to the point of this problem, so maybe I want that. Think about how I want to start this one. If we reject if that's what? Right? So let's make these two connections together. We are rejecting if p-value is less than because we're rejecting because 0 is not in there. Right? So like we're doing these two things at the same time. Like these are these are saying the same thing. So let's now think of, can you relate this to an alpha value? It's the total that's left over. One tail is 0.05. So this would be, I'm going to put a gap in between, but I'm still writing the same thing. All right, so we've got a p-value. So if we say will not contain 0, what was that association we made? So here was not contain 0, which means here was what? Which, when do we reject with the test thing? When the, so I'm taking this to understand this, and now I'm deciding which one to pick. Is this less than 0.10? Is this less than 0.07? Is this less than 0.05? So, which is the highest one that will not contain? Easy concept, tricky way to get there. And some of these that I'm going through that I say most missed to least missed, I only order them by the percent that got the right answer. Some of these, the further we get, actually would have been, I consider y'all did worse on them than the ones we started out with, because the scores were distributed almost evenly between the 5 of them, but the percent that missed it, or that got it right, is not as low because they're evenly distributed. So some of these, like this one, I would expect to, I would call this one of the harder problems of the test. This is one of those where you might have been totally lost on the test. I need you to kind of be with me on this and feel okay with it. But that's about it. Let X represent a random variable whose distribution is normal. Oh, this one I was worried about. This is another one that I wrote, genuinely concerned about this problem. This is like, if somebody says, hey, give me a problem that is like the core of your entire class that everyone should know, I would probably pick this problem. And this is problem number 9 in order. So that concerns me a little bit. Words that stand out. So that should immediately mean this in your head. So if I've got this, where do I put this? And then I now know this, so I can think of it as everybody with me there, just without even reading the answer choices. Okay, so I could go a step further, but I don't really need to. Drawn terribly. My first one is starting at 115. Wait. I want it to match above 115. So that's between 1 away and 2 away. One there. This one would be here, stated that way. B would B be any different than A? This is no. C 190, so it's here, shaded this way. D D would be between here and here. And E would be, so 1 less than 85 is here, so 1 minus less than 85 would be here. Which one has the same area of this one? It's just on the other side. Now, I could look at this one by transforming them or converting them and converting them to z-scores, which doesn't really matter. It's just a different way to think about it. What's my general equation for z? some form of standard deviation. So here, 115 minus 100 gives me 15. 15 divided by 10 gives me, you'll pick up on these really quick. This is Z is less than what? So like you can look at these and tell. This one would be probability that Z is less than or equal to 1.5. This one is what? These should all be really easy based off of what I have drawn. This one is that Z is between negative 1.5 and 1.5. This one is 1 minus the probability that Z is less than negative 1.5. Some of you would think this way to get there. Some of you would think this way to get there. And I think I can get everybody with this one, even if somebody would have gone this one first. Questions on this problem, because this is like the core of everything that we do. I need you to feel good about that. Number 13. The graphs of the sampling distributions 1 and 2 of the sample mean of the same random variable. So I'm pulling from the same thing. For sample sizes of 2 different sizes are shown. So what did I change? What's the only thing I changed? Which is, let's say this way. As sample size increases, what? And how can I write it in short words? This is yesterday. Word for word is this yesterday.
Spread.
So I told y'all yesterday in the first however many questions, this one concept came up twice. This is the second one. So as your sample size gets bigger, your spread decreases. So, and all the other things y'all are saying along with it is the exact same thing. So without even looking at these, which distribution has a bigger spread? 1 or 2?
2.
So which one has a bigger sample size? Bigger N, smaller spread. This has a smaller N because of the bigger spread. Now, all of this is because of the fact that it's from the same random variable. So like we're picking from the same, like basically like we're rolling a die. We're gonna roll the same die again. We're picking from the same sample, so nothing else changes other than the sample size, which is what I said yesterday in the problem where I think you guys would overlook that, but that part is actually experiment for. So sample size of 1 is less than sample size of 2. True or false? False. Sample size of 1 is greater than the sample size of 2. Are they the same? No, because the distributions would be the same. Sample size does not affect. Not true at all. The sample sizes cannot be compared. Not true at all. If I asked, as the sample size increases, what happens to your mean? What would your answer be? It doesn't change. Let's just say the same thing. It was 10, it's still 10. You're right, though. It's easier to say that way. Yeah.
So for A, it says the sample size of 1 is less. This one.
You're reading it with. That's why I have to literally write stuff like this. If not, I go back and forth in my head and I end up picking the wrong answer or knowing the right thing. Like I literally have to write out like side note stuff. And this is one of those exams where there's some questions there's going to be a better answer, an okay answer, maybe like one or two bad answers, and then one that's kind of in between. So like little wording stuff like this is definitely important. All right, number 10. Distribution of the diameters of a particular variety of oranges. Approximately normal, standard deviation of 0.03. This is the kind of problem that I would expect you to write as you read. I know I've talked about that throughout the year, but we're at the point where we really need to be doing that. Do not read a problem twice unless you're looking for something. Don't read a problem twice to write stuff down. The distribution of the diameters of a particular variety of oranges, I'm circling that as I read, with a standard deviation of how does the diameter affect the orange 67th percentile compared with the mean. Approximately normal in my head should be okay. I can use that. The approach you guys are going to take from this point is going to be slightly different person to person. If I know it's normal, one thing I can do, and don't draw this because I don't think most of you would think this way. I don't know what my mean is, but I know that this line is plus 0.3, minus 0.3. With me? But I probably wouldn't have thought most of you to start there. I know this, when I associate this with normal, what else do you associate with normal? The green sheet, and what do I use on the green sheet? What things are on the green sheet? Right? I can make that association. What is that equation again? Alright, so let's draw this. And I'm going through this problem slow. Most of you aren't going to take very long on this problem. How do I draw this? Where's my line? Because which way do you always shade for percentile? So if I'm shading more than half to the left, my line had to have been on the right. And this is 0.6700. Can I find that z-score? Yes, so you're looking on the green sheet in the middle for 0.6700 and then finding the z that goes out from there, which is what? It's been a while, but I need you to be okay with this. Not this is something we need to look at. So I'm going to go back to my equation. So z is 0.44. I don't know x. I don't know mu. I know sigma, which is 0.3. I can move that over, multiply both sides by 0.3. And right now I have that what equals x minus mu. Like that. What does the problem ask us? How does the diameter of the orange compare with? We've got things here, right? When I drew this picture, I knew that my line goes here. So what should I mark out? Definitely not A and B, because I'm not below the mean. How far am I above the mean? When I subtract where I am from the mean, how far am I from the mean? It wants to know how far am I from the mean. This is literally saying how far am I minus the mean. So that is your answer.
What do you mean it's like saying how, saying that the line
How does the diameter compare with the base?
Yeah, for the X, Y, and Z.
Okay. If y'all need to type up, I'm finishing. Y'all only got like a minute left. Let me go back to this picture. I'll start. I want to finish that. Tell me tomorrow that there's something I wanted to show you. I want to relate that to Z, and I think it might make sense to more people.